Hello friends, welcome to One Tech Funda. In today's video, we are going to understand the most important basics of engineering drawing. Whether you are a student, fresher, or working professional, these fundamentals will help you read and create technical drawings confidently. So, let's begin step by step. Engineering drawing sheet. An engineering drawing sheet is the base for all technical communication. It follows international standards such as ISO and BIS to maintain uniformity. Sheets come in different sizes like A0, A1, A2, A3, and A4, where A0 is the largest and A4 is commonly used for small parts. Borders, margins, title blocks, and scaling are predefined to avoid confusion between engineers and manufacturers. Title block. The title block is usually placed in the bottom right corner of the drawing sheet. It contains essential information like part name, drawing number, scale, projection method, designer's name, company name, and revision details. This helps in identifying and controlling drawings during manufacturing and inspection. Projection. Projection is the method of transferring a 3D object into a 2D plane for representation. The two most widely used methods are first-angle projection and third-angle projection. These projections help in representing different views systematically. Orthographic view. Orthographic projection shows the true shape of each face of a part. The common views are front view, top view, and side view. Together, these views completely define the geometry of a component. Isometric view. Isometric view is a pictorial representation where the object is drawn at 30 degrees angles. It gives a 3D appearance on a 2D sheet, making it easier for non-technical people to understand the part. Section view. Section view is used when we want to see the internal details of a part. Imagine cutting the part with a saw and looking at the inside. That is what a sectional view represents. Hatch lines are used to show the cut material. Detail view. Detail view is used when a small portion of the drawing needs to be magnified. Auxiliary view. Auxiliary view is used for inclined or slanted surfaces that are not clearly visible in orthographic views. By projecting onto a plane parallel to that inclined surface, its true shape can be shown. Exploded view. Exploded view shows all components of an assembly separated but aligned along their axis of assembly. It clearly demonstrates how different parts fit together to form the final product. Bill of material. A bill of material is a tabular list that includes all parts of an assembly along with part name, quantity, material, and sometimes weight. Each item in the BOM is linked to a balloon number in the drawing. Visible line. Visible lines are thick continuous lines that represent edges and boundaries that can be directly seen. These lines are the most important in defining the shape of a component. Hidden line. Hidden lines are dashed lines that represent features not directly visible in the current view, such as holes or grooves behind a surface. Center line. Center lines are thin chain lines with long and short dashes. They represent axes of symmetry, centers of holes, or paths of motion. Dimension line. Dimension lines are thin lines terminated by arrowheads. They are used to indicate the exact size or distance of a feature. Datum. A datum is a reference point, line, or surface from which measurements are taken. It is like a base or origin in measurement. Dimension. A dimension is the numerical value indicating size, distance, angle, or location of a feature. It is usually given in millimeters as per ISO standards. Tolerance. Tolerance is the permissible variation from a specified dimension. No manufacturing process can achieve exact size, so tolerances ensure functionality even with small variations. Limit dimension. Limit dimensioning specifies the maximum and minimum acceptable sizes directly. This method avoids confusion and makes inspection easier. It is widely used in mass production. Bilateral tolerance. In bilateral tolerance, variation is allowed on both sides of the nominal size. You can see the examples here. This type of tolerance is common when variation in both directions is acceptable. Unilateral tolerance. In unilateral tolerance, variation is allowed only in one direction. You can see the example here. This is used where going smaller or bigger is not acceptable due to functional requirements. GD&T, Geometric Dimensioning and Tolerancing DAT. GD&T is a symbolic language used to precisely define part features. It controls shape, orientation, position, and runout with standard symbols. It reduces ambiguity and improves interchangeability in mass production. Almost every modern industry relies on GD&T for quality assurance. Hole. A hole is a circular feature, which may be through or blind. It can be plain, threaded, or countersunk depending on its use. Slot. A slot is an elongated hole, usually rectangular or oval. It is used for guiding, adjustment, or accommodating keys. Slots are often dimensioned with length, width, and radius at the ends for easy manufacturing. Fillet. A fillet is a rounded inside corner. It is used to avoid sharp corners. Fillets improve strength by reducing stress concentration. Chamfer. A chamfer is a beveled or angled edge and used to avoid sharp corners. Chamfers help in easy assembly and safety. Rib. A rib is a thin wall feature used to strengthen or support a component without adding much weight. They are commonly seen in castings, plastic components, and housings for rigidity. Keyway. A keyway is a slot provided in a shaft or hub to accommodate a key. It helps in transmitting torque without slipping. Keyways are dimensioned very carefully because misalignment can lead to mechanical failure. Thread. Threads are helical features used in screws, bolts, and nuts. They can be internal or external. Undercut. Undercut is a groove or recess provided to give clearance or reduce stress concentration. It is usually placed at the junction of shaft and shoulder to allow proper fitting of mating parts. Surface finish. Surface finish specifies the texture or roughness of a surface after machining. It ensures proper functioning, wear resistance, and aesthetics of a component. So friends, these are the key elements of engineering drawing basics. If you understand these, you can easily read and prepare any mechanical drawing. If you found this video useful, please like, share, and subscribe to One Tech Funda. Stay tuned for more engineering knowledge. Thank you.